Alright, I started the stream. We're going to get started here in a second. We're only going to have like a brief lecture today. Chris, Stephanie, and I talked about it, and the majority of this lecture is more unit testing stuff. Hold on a second. Let me post the link. Alright. The majority of this lecture is more unit testing stuff, and based off of feedback from students. I don't know how valuable it is in the middle of Project 2. So they gave us some resources. There's only 3 activities to go over, but they're kind of difficult activities. So we discussed it, and we decided it'd probably be better if I just walk through the activities and kind of show you guys what we could do, and then give you the activities yourself if you want to do them, by all means, and then just let you kind of go do your own thing. So I'm going to show you this stuff because there's some cool stuff, but we're not going to do any activities together. We're not going to be like, hey, 15 minutes, do this thing. Just going to kind of walk through it, give you all the solutions. Well, there's only one solution is the funny thing. And then you'll be on your merry way. So the first activity for today was activity number 1. It was just a warm-up activity to do testing and kind of get familiar with it again. So you had to build this tax class, calculate some tax based off this little equation. And then you had to export the function so that you could write tests for the function. And that's all it was. It was very similar to some of the stuff we did Saturday with like the titleizer and the disembowel and all that, where we just make a simple little function. We do some validation on that function. And then we go ahead and we write tests over it to verify that it actually works as expected. So if I go into... I'll go in and I'll run the tests, do an npm install, just so we can see them. So we've got 3 tests over this. We have add appropriate tax to an integer, add appropriate tax to a decimal number, and should throw if the input's not a number, which pretty much covers the array of what you could do with this. I suppose you could pass in a 0, see what happens, you know, but you should get 0, right? So let's look at some of the tests that they have written then. Let's look at the actual implementation. So again, we use Mocha and Chai to do our testing. Mocha creates this describe function and this it function globally for you. You don't have to import anything, nothing fancy. It's just there when you have Mocha installed. Describe is to literally describe what it is you're testing. There's no testing inside of the describe itself. But it's a function to say, this is what I'm testing inside of this block of tests. Here's my description of it. And that could be the function name, the module name, whatever you decide is descriptive enough to break down those tests into logical units, right? Inside of a describe, you can have more describes if you'd like. I showed that on Saturday, so you could have a describe, an outer describe, describing the module you're testing. So say you had a tax module and a bunch of different tax-related functions, you could have describe tax. Right? And then inside the describe, you can have nested describes to then describe the functions you're testing. So we could have a tax description, and then we can have the calculate tax describe. And in there, when you're ready to actually write the tests, you have these it functions. So you're describing what you are testing, and then you are testing it, right? So it is the behavior that you're testing. It should add appropriate tax to an integer. And so for this test, we have an integer 4. We calculate the tax on that 4, and then we should get, based off of our implementation of the tax function, 4.32, right? If that comes out as equal, then good. Boom, your test passed. Your function functions as you would expect, and that's good. We can verify that now. Everyone on your team can verify that. They can run the test as soon as they pull down the code and make sure you didn't botch anything, which happens. So the next test, it should add the appropriate tax to a decimal number. Okay, so we know it works for an integer, but what if we had decimals? What if the decimal calculation's weird? What if we had a decimal and we end up with 4 decimal places? That doesn't make sense because it's money, right? You only want 2 decimals. Something along those lines. You run the test, you verify that it comes out as you would expect, and if it does, you're good. You move on. If it doesn't, then you fix it, or you fix the function, or whatever, right? And lastly, just a guard test that you can run. Okay, well, if we calculate the tax on a string, potato, I don't know what the potato tax is, but we can't get that. Our tax calculator doesn't work quite that well. So we can verify that bad inputs don't blow everything up, or they purposefully do blow everything up. In this case, we do want it to stop everything because we don't want your boneheaded tax calculation to ruin the app later. So we specifically program against that. We guard against these invalid inputs with an error. So this was a quick run through of a reminder. Hey, this is how we can test. Mocha and Chai are the libraries we use, right? Any questions on this file? Anything anyone wants to see? Anything really? No? I figured as much. That's why we're doing this. So the next thing that we were going to go over today that I actually do think is pretty valuable is how can we test our APIs all the way through the pipeline, right? So we've talked about unit tests and how you can break up your code into these small chunks that are easy to test and, you know, kind of isolated from each other, so you can test individual functions, get a little bit of functionality there, and just really bulletproof it. But you can do that all day long. However, when the application's running, you have all of these units working together, right? And even if your individual units work, it's possible you're using the inputs and outputs of them incorrectly, or something's not quite wired up properly. Well, how do you verify that? Well, there's a different type of testing: integration testing, system testing, end-to-end testing, whatever you want to call it, different forms of testing that aren't necessarily unit tests, because they allow you to test the whole thing in one go, right? So they allow you to spin up the app, start from an endpoint, test all the way down to the database, get your data back, verify the response to what you wanted, verify the database is how you wanted it, and all that fun stuff, which is really quite powerful. It's a different level of testing. Maybe harder to test, maybe easier to test, maybe more valuable, maybe less valuable. Depends a lot on the app. Most people would probably agree this kind of testing is technically more valuable because it's as the user would probably use it, right? And it's the whole thing in one, but they're much harder to set up. They're generally much more brittle because as databases change, or if data's weird, or if you do something that you can't quite do in the app, is it really a true test? It's hard to say. But you can do it. So Chai actually has a nice resource called Chai HTTP. It's another package that you can use as a plugin to Chai. You install it, you require it. Chai has a .use function. You use that and you pass in your plugin, in this case Chai HTTP. And now Chai has the ability to spin up requests and take response from an HTTP server. In this case, that is our code, right? So imagine if you had the full app. We have a server.js that creates an Express app and starts it, right? And then we might have our models folder, which has all of our SQLized models in it. And when you import that in, you get that DB object, and you can call sync on the DB object and kind of like set up your database, right? So what you can do with this Chai HTTP, you can basically spin up the server, spin up the database all fresh, and kind of test an endpoint in isolation. So what happens if we create a user without anything else in the database? Does it work as we expect? So this before each is something we haven't seen yet. Mocha has special functions that you can use that they're like hooks, right? So there's a before and a before each, and a before runs before every test in a describe block. So if we had before like that, you have something like that, and before any of the tests run, this is executed, and you would see in your console log, this is first. It runs one time, the first time you run the tests, right? You run it again, it'll run once again, but it doesn't run every test. Before each is what you need if you want to run something before every test. In this case, we do want to run something before every test because we want to blow away our database and restart the server. So Chai request restarts the server. db.sqlize.sync force true is going to obviously wipe our database, right? Because it rebuilds the entire thing from scratch. We already know with SQLize when we want to, make a serious change or just kind of blow everything away, we use force true on that sync. So what we're saying is before each test, wipe the slate clean. There's also an after and an after each, which do the same as their before counterparts. After each test, do this. After all the tests, do this. So if you need final validation or cleanup or something. And since we're using a database, an after might make sense. after all the tests are done, you may want to do another force true on the database, right? Because then you'll leave it in a weird state after your last test, and you don't want that. It makes these even harder to write. So it should find all examples. So this example code, imagine that you put this into your app, right? Say we had a to-do app, find all to-dos. You can use your database instance from SQLize, and you can do a bulk create. So we create a bunch of data, right, in this test. First thing it does. That's all created. We're good. We can use this request object that we created with chai HTTP and do a GET request on an endpoint. So say we had API to-dos. In this case, we have API examples. What happens when we do a GET? Well, we're going to get back an error, an error, potentially an optional error, null or an error, and then the response. The response is going to be our JSON object. That's all it is. And then the error is just if we had an error. So you could go ahead and you could run, on the response body, you could run tests. You could be like, expect response body dot title. Or actually here, we could do text, because we need to get all of these examples, text to equal and first example. Right, or maybe this comes back as a an array because we have multiples, so it looks something like that. But basically what this allows you to do is to literally create data, get it from your database as you would from Postman or something, and validate that it's exactly as you would expect. There's no weird logic there that's going to mutate that data before it goes in the database. It's not coming out all funky. You have all the properties that you would expect coming from the database and that response and all of that fun stuff. So chai HTTP is really the cool tool here that I wanted to show off how much you could do with it if you wanted to do full end-to-end testing, right? So obviously this leaves out the HTML part, but that's fine. That's a whole different can of worms. We won't worry about that really until we get to React, where you can do React testing. But for everything else, the bulk of your logic is right here in the API, right? Your views should really just take an object, maybe iterate over it, or just show some properties, but nothing else. You shouldn't have complex logic in your views. You should have it all in your controller. Your controller can orchestrate putting the data together and giving it to you in its final form, right? So this is end-to-end testing example of it. This whole exercise was actually just to give you this file, say, change it to work with your project and run it, which I honestly thought was a pretty hard exercise and didn't know how much value it was going to add right now. I was hoping it wouldn't, you know, kind of bog everyone down and get people into the particulars of what their project's doing more than the particulars of testing. So if you want to use this file, by all means do it. This is a great file to use as an example for setting up end-to-end testing. Any questions on this GET request? We're going to look at a POST request next. Any questions on this? Cool. So again, chai HTTP is really the best thing you get here. You can learn about that module. Let me actually Slack out the docs for that really quick too. So if you want to look into it, you can. All right. So let's look at the POST example. So again, we use chai HTTP. We spin everything up. We spin up the server here. We sync force true on the database, blow everything away. And then we can create an example where we save an example to the database, right? So again, we use our request. We call a post on our whatever endpoint, API/to-dos, API examples, and we just send a JSON object just like you would from jQuery, right, with your $.post. Nothing crazy there. And then you get a potential error and a response back. And just like the GET request, if your response has something, you can validate that. If it's a 204 and you just want to make sure it happened, you can validate that. Whatever you need to do, you can do it from here. And chai HTTP gives us the flexibility and the power to kind of do this full endpoint testing from our Mocha tests. So you can have, you know, you can actually have two folders maybe. You have a unit test folder and a system test folder or something like that, so you don't have to run them all together. But more tools you can use to, again, validate that the code you're writing doesn't break anything. It's very, very powerful. If anyone can get this into Project 2, it's very useful, but I suspect it's going to be very hard to do at this point. If people can get it into their third project, though, that's going to go a long way. And I will say, I recommend you try to do stuff like this for your final project, because even if your final project's overall functionality is not super grand because you spent a lot of time on these tests, if you have a bulletproof app that's tested thoroughly and you can prove that, hey, we did our work up front to make sure this thing's tested and architected well, it works well, that's going to say a lot to potential recruiters, right? You're willing to learn this and do this up front. So I do think there's a lot of value here because that's what people want. They want safety in their code. They want to know that they can deploy code that's robust and not going to break. The worst feeling in the world as a developer is when you spend a ton of time on a feature, you hand it off to QA or even worse, a customer, and the first thing you hear back is it didn't work. And that happens a lot. It's very, very hard to write code that just works up front. As a matter of fact, it's effectively impossible. I know Stephanie, being in the industry for a long time, can tell you that's like the hardest thing ever to do. So writing a lot of tests, writing them well, and knowing how to do this is only going to help you because you're inevitably going to make mistakes. So learning this, getting good at it, is going to just mean so much to potential recruiters. So that's my soapbox about why you should care about these tests, because they really are powerful, and in any serious dev shop, you're going to do a lot of them. So get used to it. Now, the other thing they wanted me to talk about today that you could do, I'm not going to show you, but you could do. Did you have a question? No. Okay, I thought I saw your hand go up. You can actually update Travis or any CI pipeline to run these tests before it does anything else, right? So we saw that you can have it build your code, make sure that that's good, or deploy it, or whatever, right? So you can have these pipelines where you send the code up, you push to your master branch, Travis, Jenkins, AppVeyor, Circle CI, whatever one you use, can build your code, right? So it can just do your NPM installs, make sure it's good. It can run your tests, make sure they all pass, run your system tests, even if you have it set up nice, make sure those all pass, and then bundle it up and deploy it somewhere. So your customer either has to click a button, or you just hand it to them in a zip, or whatever you do for your deployment, or maybe it's deployed already to the web and you don't do anything else. So you get this pipeline that always runs whenever code goes into your master branch, verifying that everything that happened is still good and you didn't break anything in production. And that is extremely powerful. And that is what people have been working for the last decade or two to master, right? How do we get our pipelines built so immediately we can know if something bad happened, right? Because the ideal scenario is every line of code I write, I can push to master and immediately know if it affected production or not, take it out, or prevent it from going into deployment. Now, obviously, you can't push every code individually and every line of code individually to know that, but the smaller chunks you can get, the faster you can know that these problems exist, the easier it is for you to fix them and keep them from going into production, right? And so that's what everyone's trying to do, and using a combination of these system tests, unit tests, something like Travis, to build this very complex pipeline that runs automatically, does everything for you. It's phenomenal. And if you can get it set up and set up well, it's extremely powerful and extremely impressive, right? So I do recommend, if you're interested in this DevOps stuff, you learn more about it, because it's like the hot new thing, right? Everyone wants a really good DevOps engineer for their stuff, and that's a path you can take too if you think it's more interesting than dealing with just the code. Being a DevOps engineer means a lot today, and there's a lot of big web companies and companies in general that really need that. So that's just an aside. Any questions on any of this stuff? I know it's kind of a quick, just here you go, here's some stuff you can do. But I didn't want to take up a lot of your time today going over this stuff that I feel like is kind of injected in there without any forethought to the project, personally. So that's kind of what's on everyone's mind. We all know that. So we don't expect you guys to be like, yeah, unit testing, can't wait to do a bunch of that today before I go work on my project, which is what I really want to do. So any questions on any of this? Okay, then you can go work on your projects then. We're good with lecture for today. Go work wherever, and if you're still here for some reason at 10, I guess, then I'll kick you out. So, yeah.